Yeah. So guys, are you hearing the term data engineering everywhere? Are companies hiring data engineers with huge salary package? And most importantly, do you want to become one? Okay, so in next 10 to 15 minutes, I will clearly explain what is data engineering, what is ETL tool, what data engineers actually do, and most importantly, what is Azure Databricks and why it is dominating the market. Okay, let's get started. Data engineering is the process of collecting, transforming, and preparing data so that it can be used for analysis, reporting, and machine learning. In simple words, so we are going to collect the raw data, and as per the requirement, we will be cleaning and transforming the data. Okay, so this is what output of this whatever data engineer do. So this business insights he will uncover. So he will create some dashboards, he will generate some reports. Based on these reports only, business firms are going to, I mean, leadership will take decisions. Okay, they will plan their business efficiently. They will go for innovation and growth. Okay, so data engineer will uncover business insights from raw data. Data engineer's work is converting this raw data into valuable insights. Okay, converting raw data into valuable data so that business leadership will use this data for this business growth. Okay, yeah. So companies and every organization generates data from. So Gopi, from where we will be data, where data is coming from. So it can be coming from web applications, websites, mobile apps, IoT devices, banking transactions, social media. Okay, so you can see social media. How many posts are posted in 1 minute? How many Facebook videos are generated in 1 minute? How many Instagram comments, how many Instagram likes, how many Instagram videos, how many Instagram short other things are posted in 1 minute. So can you think of it? So not only this social media. So if you take Amazon, so Amazon website or Amazon mobile app, how much data it is generated in every day. So if you take Amazon, how many users are purchasing from Amazon? How many users are making transactions from Amazon app? Okay, so like this data is okay growing day by day. That's why this much what we can say demand for data engineers. Because so who will be collecting this data, who will be processing this data, who will be giving the insights and all? So data engineers. Okay, so data engineers will do this. Okay, and so guys, I already told you in my previous sessions, 50% of the organizations move to cloud. Okay, so remaining 50% are moving to the cloud in next 5 to 10 years. That's why this much huge demand for data engineering. Okay, so Gopi, all good. This raw data is very messy, right? The raw data which we collect from organizations or companies or social media logs, all this. So this is very messy and unstructured. Okay, so it is in different formats. So it is different stored in different systems. Okay, so a data engineer's job is to organize and prepare this data. Okay, so if you want to prepare any, if you are working for Amazon, so you need to prepare some report. But the data, so you can see it is very messy. Okay, so the data, customers data is where it is in SQL database. Okay, so products data is where from the data warehouse. Sales data is from Amazon app. Okay, so these three data we have to collect. Okay, so we have to collect all this data, we have to clean, and we have to join this data, and we need to perform some analytics. We need to perform, before performing analytics, we need to transform this. So this much work is there. Who will be doing all this work? Data engineer. It is data engineer's job. Okay, yeah. What is it? ETL. So data engineer's job is to prepare this ETL pipelines, right? So what is ETL? ETL stands for extraction, transformation, and load. Okay, extracting the raw data from the different systems. Okay, extraction means collecting. Okay, so collect data from sources like database, okay, files, APIs, okay, from external websites and all. Okay, so collecting the data is called as extracting. Transform, transfer. Okay, so transform means cleaning the data. Clean the data, remove null value. Cleaning means many things are there. Cleaning means removing null values, removing duplicate values, removing invalid data. So this is cleaning. Transformation means filtering, join, union. Okay, so and applying some rules, business rules, all this comes under transformation. Okay, so then loading. So L stands for loading. Okay, so loading means so you have performed all this. You collected the data and you transformed as per the requirement, and we need to load that data into target systems. Like, so our target systems can be data warehouses or SQL database or data lake or delta lake. It can be anything. Gopi, what is the data warehouse? What is this data lake? What is this delta lake? Okay, yeah. So this is the backbone of data engineering, guys. So this ETL process, it is backbone of data engineering. Now the big question is, what tools do we use for this? Gopi, what tools we are going to use? Okay, so we will be using for this. Yeah. So a data engineer, okay, so a data engineer typically uses, okay, so what he will be doing? So a data engineer typically, okay, so builds data pipelines. This is data engineer work, guys. You can ask me, Gopi, what data engineer will do daily? So if I join as data engineer, I will take your course and I will, so by 3 months, I will complete everything. Okay, so what I have to do? Okay, what data engineer will do typically? Okay, so he builds data pipelines. Okay, so he will be working with large scale data, and he's going to handle structured, unstructured, semi-structured data. Okay, so he optimizes the performance. Okay, he won't build only ETL pipelines. So he will be taking care of performance, optimizing the performance, and he's going to ensure. So he will be taking care of this data quality. Okay, so ensures data quality and work with. So data engineer will be working with cloud platforms like Azure. Okay, so one of the most powerful tools used today is Databricks, Azure Databricks. Okay, Gopi, what is this Azure Databricks? Okay, Azure Databricks, it is a unified data analytics platform built on Apache Spark. What is this unified data analytics platform, Gopi? Okay, so in a data team, we will be having data engineers, data analysts, data scientists, data ops guys. These 4 people will be working for data. Okay, so everyone, so data engineer, he uses Databricks, data analytics people, they uses Databricks, and data scientist people to perform their A and ML work and to run their statistical models and all. They will use this Databricks, and data ops guys to fix the data, to prepare the data. So they will be also using this Databricks. Okay, everyone. So in a data team, everyone uses this Databricks. That's why it is called as unified data analytics platform. Okay, it is both data, I mean not both. So everyone, data engineers, data analytics team, data science team, data ops team, everyone uses this data bricks. Okay, in simple words, what we can do, what we can say, it is a powerful engine that processes huge amount of data very fast. Okay, why, Gopi? Okay, so why it is very fast? Okay, even though the data is very big, 10 GB, 20 GB. Okay, so why it is performing that much fast? Because it has master slave architecture. Okay, so master slave architecture means, so I already told you, it is built upon Apache Spark, right? So what is Apache Spark Compute Engine? Here, so in this Apache Spark Compute Engine, you will be having one driver and many workers. Okay, so if the data is very small, we can use one worker. If the data is very big, we can increase number of workers. Okay, so the work is divided. The work is divided. Many workers will perform same task. So I have one task. The data is very big. So I can divide my data among these workers. I can divide my task among these workers. Okay, so who will be planning this execution and all? Driver. So what driver will do? Driver will plan the execution, and many these workers will perform the task parallelly. Okay, they will execute the plan. Driver will plan the execution plan. Okay, so this is what this Apache Spark Compute Engine is. That's why we have powerful compute engine, so that, okay, so huge amounts of data also processed very fast. That's why I told you starting only, Azure Databricks is, okay, heart of the data engineering. How data engineers handles this big data? Using this Databricks only. Okay, so that's why it is called as big data analytics and processing tool. Yeah. So Gopi, why do we use this Databricks? So traditional systems, guys. So traditional Gopi. So earlier, before this Databricks, what we have? We have traditional databases and traditional ETL tools. Traditional databases like MySQL Server, IBM Data Stage. Okay, so PostgreSQL. So these are the traditional database. They handles only small amount of data, and they handles only what? Structured data. They cannot handle unstructured data. They cannot handle semi-structured data, and they cannot handle what? Big amount of data. So ETL tools also same. So ETL tools also have traditional ETL tools have limitations, like they cannot handle unstructured and semi-structured. They cannot handle huge data. Okay, so that's why. So in a big data world now everything. So every organization is generating terabytes, megabytes of data, right? So traditional databases and traditional ETL tools will not work now. So they won't support our business. So that's why everyone are moving to this cloud and big data processing tool. So among all cloud tools and all big data tools, Databricks is powerful, very powerful, because of this master slave drive architecture. Okay, Apache Spark computing. Yeah. So traditional systems are very slow and they cannot handle big data efficiently, and they struggle with performance. I mean, so they will take days of time to complete one task. They are going to take hours, days of time. Okay, and the performance also not good. Okay, so I mean, even though they are performing, so they have limitations. Okay, optimization is not possible there. So Databricks solve this by how it is solving. So because of this distributed computing. Distributed computing means we have many workers, right? We can assign our work to many workers. So the data is, the work is parallelly processed. The data is parallelly distributed. Okay, so this is what distributed computing is there, and parallel computing is there. And high performance, yes, because of all these reasons. And one more thing, scalability. Scalability means based on the data we can upscale or downscale. So if the data is very big, we can increase number of workers. If the data is very small, we can decrease our number, this worker size. So if workers are more, the cost is high. Okay, compute is powerful, cost is high, no problem. I can compromise for cost, but I want my work very fast, because now everyone needs what? Real-time processing. Ready to effort for money, but I want everything in real time. So if you take banking transactions, so if I want to send money to my friend, so if my 500 rupees or 1000 debited from my account, means immediately they have to credit in my friend's account. So everywhere they want real-time processing. Okay, so this Databricks works very fast. Okay, so that's why. So it supports both batch processing and real-time processing. Okay, so and if you take Instagram, LinkedIn, or Facebook and all, so how they are working? If you post something, so it has to reflect in your friends, and it has to reflect within microseconds, not nanoseconds. Okay, so if you comment on your friend's wall, it has to reflect in my nanoseconds. Okay, how it is happening? Because of this powerful compute. Okay, yeah, Gopi. So this is good. What are core components, Gopi? So what are core components of this Databricks? So Databricks has clusters. These are 3 or 4 powerful and core components. Okay, so one is cluster, next one is notebooks, and third one is Apache Spark engine. Okay, what is this cluster, Gopi? So cluster, I told you, right? So Databricks works on Apache Spark compute engine. So in Apache Spark compute engine, you will be having one driver and many workers. Okay, so these one driver and many workers together is called as cluster. Okay, so these are what? Clusters are nothing but virtual machines that process data. So this cluster of machines will be there. Not only one mission, cluster of machines will be there for parallel processing. Okay, we can upscale or downscale. We can increase this number of machines. Okay, so if the data, I already told you, right? If the data is very big, I can increase worker nodes. Worker node is nothing but virtual machine. It is also one virtual machine. We can increase virtual machine. If the data is very small, okay, so then we can decrease this virtual machines. Okay, so can scale up or down. We can upscale or we can downscale. Auto scaling also available. Okay, so Gopi, so I want this auto scaling. Okay, based on the data, my Databricks has to decide. So whether you want more number of workers or you want lesser number of workers, it has to do automatically, not manually. So we can do it manually and we can do it automatically also. So that auto scaling also available. Okay, so next core component is notebook. So notebook means, so here only we will do all our development. Okay, so where we write our code. Okay, so we will write how to ingest the data, how to transform the data, how to load the data. So everything we are going to write down in notebooks. Okay, so write code in Databricks. What is the beautiful feature of Databricks is it supports Python, it supports Scala, it supports SQL, it supports R languages. If you know one language, so you can write. So if you know Python, well, so you can use Python everywhere. If you know SQL, so you can do all the coding in SQL. If you know Scala, you can do all the coding in Scala. Okay, it supports 4 different languages. Okay, so here it supports R language also. Okay, so what are jobs, Gopi? Okay, jobs is nothing but for ETL, you have created one ETL workload. So what we can do, so this one we can create, so you don't want to run it manually. So you want to automate it. How can we automate? We can create job. Okay, so job means extraction, first notebook, transformation, second notebook, loading, third notebook. So altogether we can keep inside these jobs. First extraction part, next transformation part, last loading part. So that is called as together these 3 tasks, 3 notebooks is called as jobs. We can schedule, automate. So what we can do, we can add trigger here. We can schedule this job. So at what time you want to run? 12 a.m. So every day 12 a.m. it will run. Okay, so yes, workspace is nothing but all together. So in this workspace only you can see jobs. In this workspace only we can have notebooks, clusters and all. So everything available in the workspace only. So it is called as collaborative environment. Okay, and one more thing. So what is the main component? Apache Spark Engine. Okay, so it is distributed computing framework. What does it mean? So it is a distributing processing framework. Okay, so I already told you, right, why it is distributed, because so here you won't have only one virtual machine. You will be having cluster of virtual machines. So one driver and many workers, right? These are called as what? Driver, one virtual machine, many workers also virtual machines. So these all are what? Virtual machines only. One driver, many workers. So this is called as what? This distributed computing framework is nothing but this one driver, many workers architecture. Okay, so it processes data in parallel. I already told you how it processes. And one more beautiful thing is in-memory computation. Why it is very fast compared to other systems? Because it supports in-memory computation. In-memory computation means first you read the data. After reading the data, you performed filtering. So where this filtered output will be saved inside the Databricks memory. Okay, so after filtering, you want to perform join, where this join output will be stored inside Databricks memory. That is what in-memory computing means. Okay, so we have other architectures where in-memory computing is not supported every time. So first we need to read the data. First transformation is filtering. What it will do after filtering, the filtered output will be saved in the external memory. So whenever you want to perform join, we need to call the this output, filtered output from external memory. So this integration and this input-output rights will take so much time. Okay, so if you have in-memory computing, no input, this will delay, because here it is not writing to external disks, right? So it is not writing to external memories. So it is writing to internal memory only. So this filtered output is available in the memory. So we can easily call and we can perform other transformations also. That's why it is very fast, because of this in-memory computing. Okay, so much faster than traditional system, because traditional systems won't support this in-memory computing. Copy. What can we do with Databricks? We can do everything. So in data engineering and data analytics and data science, so we can do everything using Databricks. We can perform data cleaning. We can perform data transformations. Okay, joins, unions, aggregations. Okay, it can handle any kind of data. So it can handle unstructured, semi-structured, okay, and structured, everything. So it can handle JSON files. It can handle CSV, Parquet, Avro, text, images, videos. Okay, it will handle everything, guys. It can handle structured data like tables. It can handle structured data like Excel files. It handles every kind of data, guys. Okay, so we will be using this Databricks for building ETL pipelines. Okay, end-to-end ETL pipeline we can build with Databricks. And streaming data processing, I mean real-time processing also possible. Now every industry wants real-time processing. If you take banking, they want real-time processing only. If the money is if the money is debited, it has to be credited within microseconds, nanoseconds. So social media, healthcare, everywhere we need real-time processing only. This Databricks supports real-time processing. Okay. So what are the advantages of this Databricks, Gopi? So these are the advantages. Okay, so massive scalability, high performance, cloud integration. It supports both real-time and batch processing, and multi-language support, and inbuilt security, built-in security, easy collaboration. Okay, it supports what multiple languages, and it handles big data. How much data you have, it will handle efficiently. That is what we want, right? So data factory also handles big data if you take, but what is the problem? It will perform, it will execute that pipeline in 2 to 3 days, where Databricks will complete that whole ETL pipeline in 3 minutes, where it is taking 3 days in other traditional ETL tools or data factory also. Okay, so this is why most companies are moving to Databricks for all these reasons. Okay, so Gopi, why is Databricks in huge demand? Because companies today, they need real-time processing, they need scalable systems, they are moving to cloud and are generating huge data. Okay, so this huge data, who is going to handle? Databricks will handle, and need real-time processing. Who will be performing among our ETL tools? Which tool will be performing the real-time processing? Our Databricks. Okay, so and this Databricks supports modern architectures also. So here your project architectures will be there, right? So they cannot handle this much complex architectures. Other tools, Databricks can handle any architecture, any modern architecture. That's why so data engineers with Databricks skills are highly paid. Okay, so you can see, so you can see, so you don't require some job descriptions only. What Databricks engineer they want? They will not post it as Azure data engineer. They want Databricks engineer. If you know Databricks, they are going to pay so high salaries, premium salaries. Okay, so you should learn on Azure Databricks if you are a fresher and interested in data field. You are a SQL developer, or you are working for ETL tools and you want to switch to data engineering, or you want to go for, so you want a high growth career. So if you are looking for all this, then you can what? So you can learn this Databricks. Okay. Yeah, so in this course, I will teach you, okay, so complete data engineering concepts, guys. Okay, so Azure Data Factory, Azure Databricks, real-time projects, end-to-end pipeline building. Okay, so everything will be taught here. So step by step, from basics to advanced level. Okay, so if you want to build a strong career in data engineering, this is the right time. So subscribe to our channel and let's start this journey together. Okay. Thank you guys.